Was the inventor of this an angel or a devil? Power transmission seems simple, so why use dangerous high-voltage electricity? Electric current is created by the directional movement of electrons in a wire. However, all wires have some electrical resistance. As electrons move, they constantly collide with the atoms in the conductor. These collisions heat the atoms, converting electrical energy into heat, which results in energy loss. According to Joule's law, the heat produced equals the current squared multiplied by the resistance. This means with constant resistance, a larger current results in greater energy loss. So how can we reduce this loss? The answer is to increase the voltage. This is because power equals current times voltage, and voltage itself does not cause this heating loss. Understanding this, let's see how a transformer steps up the voltage. Let's start with an experiment. When a coil moves back and forth near a magnet, it cuts through magnetic field lines, which generates an electric current. Now we'll replace the magnet with a second coil. If we pass direct current through it, it creates a steady magnetic field. But since nothing is moving, no current is induced in the other coil. But when we switch to alternating current, AC, the changing current causes the magnetic field to constantly reverse direction. This changing field now passively cuts through the left coil, inducing a current within it. This is essentially wireless power transmission. This is the principle behind wireless phone charging. Now back to our topic. We'll change the setup by winding the coils around an iron core. The core, made of silicon steel, helps guide the magnetic field more efficiently. In this system, current enters the coil on the left, which we call the primary coil, and the current is then output from the secondary coil on the right. According to Faraday's law, the voltage is directly proportional to the number of turns in the coil. Therefore, if the secondary coil has more turns, the output voltage will be higher. By the same logic, if the primary coil has more turns, the output will be a lower voltage. Let's see the whole process. Electricity from the power plant is first stepped up to a high voltage for transmission. It's then stepped down at substations. Finally, local transformers step it down again to be safely delivered to our homes.
This is the basic principle of the transformer. Did you get it?